This presentation is a bit different from what you have seen on the web. This is the first actually tutorial that you will understand the difference between remote sensing, active and passive, the differences. First of all, in applications such as Agisoft Metashape, you can import the files, go to the workflow and just add photos to see the photos. But before going to the photos, I'd like to tell you a bit information about the difference between active and passive remote sensing. In active remote sensing, actually you need energy source like a laser to go and hit somewhere and you will check the reflection. You'll measure the reflection. But on a passive remote sensing, it's just like taking photograph. As you can see, I'm looking at the details of this photograph, and then when I click on the detail, you will see that the type of the camera that I have used for this one, it was an iPhone, Apple iPhone, and the size, the date is 2002 something, and exact time, and also the DPI dot per inch, the pixel size, dimension. Pixel stands for picture element, and the detailed information about the location, which is very important. When you activate your location on your mobile phone, in this iPhone 7, a couple of years ago, you can easily, it's ISO2, it's a standard for the negative many years ago, and now they are just simulating on a digital photo and location, longitude, latitude, and altitude, which is very important for your 3D model, and you can easily export KMZ file and import your KMZ file on a Google Earth. So it will be kind of location-based 3D model. The first step you have to do, actually, you have to import all of these files inside the Agisoft Metashape, as you can see, and then you can easily create the model based on the procedure that I'm giving you step by step, and then you can export KMZ file and import it to Google Earth. For the time being, I'm just trying to copy and paste the address bar of this file into the add photos, and then I paste it here, Control C and then Control V, and now open to import all the photos. Once I imported all the photos to here, I'll spend time to do photo matching. What is photo matching? It's another story. Now you can actually put the orbit, put it exactly, grab and drag and drop it exactly on the middle of the sphere, which is for rotating, orbiting the Z and X and Y axis when you want to orbit your 3D model after creation. In the first step is align photos. What is behind this aligning photo? It's a kind of photo matching procedure, which is very, very important. In a photo matching procedure, actually one pixel or picture element from one photo will be checked, will be matched with all the pixels of the adjacent photo, which takes a lot of time and a very heavy overhead on a system and central processing unit. So, for the time being, I'm putting the key point limit, as you can see, and because the number of the photos is just 16, so I selected the highest. It will not take that much, and also those parts that the system is processing, I'll try to cut it from the video, as you can see, and then the tie point is very important. The tie point means those points that can be found in images for matching, which is very important. The system automatically extracts the tie point from the photos, and then it will be matched. For the time being, I'm just trying to show you what is the behind, which is very important to know behind these systems. Actually, epipolar geometry, as I'm just searching here, just to show you what's epipolar geometry, is very important to understand. It's a mathematical operation behind this story. I'll explain by detail, so that not by detail, in a way that you can understand, because it's a mathematical operation, and there are a lot of things that I want to talk about this epipolar geometry. Epipolar geometry is a system to reduce the overhead of the system, or the overhead of the central processing unit, or memory. As you can see, in a epipolar geometry, actually the system can calculate the pixel on a left image, one pixel on a left image, it can calculate on a line of second image, not on a whole second image. So instead of comparing one pixel in the left image with all the pixels of a right image, which can take a lot of time and a very big overhead on a processing unit, central processing unit, and GPU, graphical processing unit, it will compare one pixel on a line of pixels in an adjacent photo. And this line of pixels can be calculated based on mathematical operation, and it can be detected from the second or right view, or right image, or second image, it doesn't matter. So instead of comparing one pixel from the one image with all the pixels from the adjacent image, it will compare one pixel with the line of pixels in the adjacent image. This is the way that it can increase the power of, what do you call it, the process of photo matching and creating the 3D model. As you know, we as a human, we have eyes almost 6.5 centimeter further from each other, and you're taking photos, stereo photos, simultaneously from different places. If you look at a face of a beautiful lady or girl, and you just close your eyes, you can easily imagine exactly how her face looks like. I mean, you can create the geometry in your brain. Why? Because you can actually do photo matching just like a mainframe, very, very fast and very easy to do that. For the time being, let me just show you to the 3D point cloud that has been created from the, what do you call it, has been created from the photo matching, and now it's time to select those parts that should be involved in the 3D modeling. So I'm not going to create the 3D model from everything. For the time being, I can use options such as select, and then select a part of this one, and then you will see how I'm going to delete those parts that I don't want to let them to be in the photo matching procedure. Okay, this is a cemetery in Shadabad, Mashayikh, very old cemetery and a historical site. It's just like a heritage landmark, and you can search for what do you call it. So as you can see, I selected and then invert selection, and once I click on invert selection, press the delete button on the keyboard, and you can delete all the rest. I mean, so I don't need them to be involved in the team generation triangular irregular network. So now I can just click on the build model. As you can see, the one which is about laser scanner, it's based on active remote sensing. In active remote sensing, as I mentioned, you need a power energy source like a laser to go and hit somewhere and come back. But this application also can be used for photogrammetry, as you can see. So you take photos, so you don't have the energy source, and it's the reflection of the, what do you call it, sun. And now this next step, it's build model to create the model. So I'm not playing with the laser scan, because in laser scanners such as X300 you can do this. I'll give it to you in another lectures. For the time being, as I have less photos, almost 16, with more than 18 overlap photos, I'm asking the system to do it with a high and or highest. And even though in a part which is called advanced, if you click, you will see many different things as well to add or to put the tick mark. And for the time being, I'll come to OK, and then I'm not clicking on the advanced to see the rest of the thing, just to create the model as fast as possible. And the model is already created, as you can see here. A very nice model of the stone. I have no idea who have created this stone over there, but it's a funny stone. I mean, to be honest, it's just some like genital part of human being somewhere in the cemetery, as you can see. So what I have done here, actually, the parts which are out of the 3D model, also I delete all of them. For the time being, I'm just clicking on the build the tiled model to create the tiled model. For this one also I can different options. Let's say it doesn't matter. I mean, you can try different parts of different options and see the result, and do it again and again and again until you get completely expert in this application. I mean, it's not that much difficult. You can create the model of everything easily, and export in any format. For example, the number of the points you can select, for example, and then click on the advanced, and you will see many other options to add or to reduce. For the time being, some of them I will leave them as it is, and then I will click some check marks, and it's just try and error. I mean, it's not that much big issue, and you can easily continue, try, error, and then you'll find it that it's not that much difficult, and you can easily manage everything over here. So for the time being, I'm going to click on the OK, and then finalize the 3D model, as you can see. And now this is the model, and now the next step is build texture. But before building texture, you have to save it, otherwise it will not function and will stop. It will ask you to save it. As you can see, I saved it as a Shadabad, the name of the village, almost 10 kilometers far from Tabriz in East Azerbaijan, Sharqi of Tabriz. Now let's go for the next step. So finished already. And now I can delete some of these points just by clicking delete, or I can use another form of selection. As you can see here, it's called free selection. this one and then free selection. Now there are many other stones on the sky that I don't need them, so I can delete all of them at once, just like this one. Once I select everything, and then I just the photos will not be deleted, so for sure the photos will not be deleted. And now the 3D model already created based on what we wanted to do. The texture also created. Now we can export in different formats, KMZ or X3D or whatever. I show you the list of the thing that we can export. So this is the 3D model only from 16 photos that I have taken, and the final result you will see here, workflow, and then come to the next step. So as you can see, no worries, just workflow and step by step go further. You will finish. No need to create the DEM digital elevation model, and it will create automatically the number of the polygons based on, not polygons, actually triangles. It's a kind of team, because as you know, each plane surface can pass through 3 points exactly, but not through 4 or 5 points. That's why the 3D modeling softwares like laser scanning softwares or Agisoft or reality capture or many others, they are just creating based on team, triangular irregular network. So it's a kind of team-based system which can be created for creating the 3D model, as you can see. And now after creating the model, you can upload it to Sketchfab, or you can put on the exact position in Google SketchUp. In SketchUp, not Trimble SketchUp, not Google, because the application of SketchUp purchased by, what do you call it, Trimble. It's a German company. So those parts that you don't have enough photos, it will be whole, as you can see, and the system cannot fill those holes, even though the application which is called tools, there is a part that you can fill holes, yeah, close holes. But some of the holes, they are too big to be closed by the application, and it doesn't matter because it's a missing data, so you don't have data from that place. That's why the system cannot do photo matching, and that's why it will remain such a hole over there. And now we can export the model, and then the different types. There are many, as you can see in the list. There are many, so I'm not going to discuss one by one. We have WRL, VRML, X3D, 3DS, even GLB as a form of, what do you call it, NFT, that you can sell it in OpenSea or different places. It doesn't matter. So as you can see, there are many different formats, and you can export even for printing, STL, and many other formats. For the time being, I'm going to export KMZ file, because the KMZ file, as I mentioned, if your photos, they are location based, your model also will be location based. Then if you double click on this one, the Google Earth will open this. KMZ file actually is a zip form of KML. What does it mean? Actually, if you rename the extension of KMZ file to zip and extract the file, you will see one CLADA file, one image file as a texture, and one KML file for keeping the location of the place. So this is the main reason that actually you can easily create the location-based model and then import it to SketchUp, and then you can share it location-based model. Even though if you send it to anyone and he just opens the 3D model, it will be opened on a Google Earth. But the problem here, it's a big displacement. Sometimes the elevation of your model is not the exact elevation of the model on the Google Earth. As you can see here, I'm just making a copy of this one, just pressing the control and dragging and dropping the file in the same place just to make a copy, and then I'll rename it, as you can see, to KM to zip, the extension, not rar. Be careful, not rar, just zip. And then it will tell you, okay, if you change it, blah, 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 I tell you, okay, that's none of your business, just do it. Shut up. Then, once you create it, if you double click on this one, you will see one KML file, as you can see, and one DAE file, which is a CLADA file, the 3D model of the object, and one JPEG file, which is the texture of the 3D model. Now, you can easily, actually, what do you call it? You can easily double click on this one and then open it on a Google Earth. This is the whole story that you can actually do it. For the time being, I'm just trying to open the JPEG file. The system cannot load it because it's a bit heavy file, and it doesn't matter. I'm just closing it. It's just JPEG file based on image, what do you call it, coordinate system can go on the 3D model. For the time being, as you can see, I cannot see the model here, so I have to what do you call it, change the elevation. Sometimes even after changing the elevation, it's not easy to see the 3D model on the Google Earth because you have to set the elevation, yeah. And sometimes because the model is very heavy, that's why you cannot see the 3D model on the Google Earth. So sometimes you need very small models, so the quality of the model is very low, and I mean the quality is very low, so it goes no use to see on the Google Earth. You can right click on the KMZ file that you have imported just to see some of the pictures. I just want to show you. This is the pictures from Shadabad Mashayikh Cemetery, which is a historical place. And then if you see here, you can come right click and properties and altitude, and then here you can increase or decrease the height of the 3D model, which is very difficult procedure to put exactly on the ground. To be honest, the best way is to use SketchUp to put the model exactly on the SketchUp on its real location, and then export KMZ file. Then if you double click on that KMZ file, it will open it for you on Google Earth exactly on its own position, which is very good in this way. So for the time being, I'm not going to give you more headache on loading this 3D model on what do you call it, Google Earth, but I have many other models that I already uploaded to Google Earth, but they are very, very big, like Harira that you can see on the Google Earth. And I'll try to show you as well. Okay, this is the way that you can see here the 3D model. I hope that you'll enjoy this method for 3D modeling, and then I hope that you will do your best to give it chance and give it a try, and then see how can you create a 3D model of a statue in Germany or some other countries in a detailed information, as you can see right now.